Did I do everything? I don't remember. I need to check. Are we live on Restream? Yes. And we probably want to send out the chat message. Welcome. Welcome to Code Hangout number 232. Today we're going to split some outlines into different settings. This has been a long pending request. And the idea is basically, and I don't know if this is a good puzzle to show it off. I might have to add some background colors perhaps. If I do this. Yeah, so right now on this one, the outline is clearly off. So outlines on elements off. So if I switch this on, I have to make this bigger. Basically, there's a faint outline around this orange line above the blue. But for example, not against this yellow, because I think the yellow's on top. And the request is basically, yeah, and we have a digit outline, right? And the request is basically to separate the outline on the visual elements. So for example, can I make it clearer with something like this? Yeah, so we have an outline around the arrow. We don't have it around the cage lines, which is interesting. I wasn't sure if it was all elements or not. And I'm going to do a few different colors, maybe something very dark, like brown. We don't really have black. Yeah, so on this brown, you can see the outline very clearly. Hey, Keith, how are you doing? I'm doing all right. My nose has been itching all day. Some sort of reaction to something, I don't know. My dog is also shedding, so it might be his fault. So the request is basically to separate the outlines for the digits into a separate setting from the outlines for elements. So currently it's a singular setting. So this is going to consist of two things. First, I'm going to have to figure out exactly how I generate the outlines, because the outlines on the element are, I think, done very different from the digits. And I think they're triggered by CSS classes, but I need to confirm that. And then we'll obviously have to add the second setting. But before we do this, we, as usual, have some pending work sitting here. So we still have the markdown stuff sitting here. And I think what I'm going to do is I'm going to ensure it doesn't run automatically. And I think right now it doesn't, as we can see by this. Let me just double check exactly what it's doing here. So it's the utilities file, right? So we've added the parser here. Or we removed the old parser, we added the new parser, because we already had a parser sitting in there. Let us clear out some of this. So I'm looking for these lines specifically in the 190s. So that's in here. So I was just going to get rid of this for now. Get rid of that for now. Get rid of that for that. Yeah. And then I've basically commented out the line which does the parsing. I think that's the only real change here. No, the other change was to move the carriage return line feed handling to the end. So it used to be here, and I moved it down to the end. So we can parse everything before adding, without having to worry about HTML elements already being in there. And then line 223. Okay, no, this is this. All right. So I added this line, commented this out. So these three lines are new because I had parsing in here already in a previous commit. Okay, so I think this is safe to commit. So here we're gonna I'm just gonna make a comment. Added md parse, but parsing is not enabled. All right. And then this is a fix for a background image issue. And I'm trying to remember, I had this already open. The question is, was it in this browser? Because this was a reported issue. Let me just double check the chat message from Juggler. And it was about a specific puzzle, which I believe is this one. Right, and it wasn't perfectly easy to trigger it. I think I had to go like full screen, and then I had to kind of do this and then change something, and I think then restart the puzzle. Yeah, you see it does this. So let's check this on localhost. Right. So we have this. We'll do something like that. We restart the puzzle, and now it's rock solid. Yeah. So I think that's fixed. Let us review the code quickly. So what exactly are we doing here? Let me make this a little bigger. Can I think I can do this. Let me do this a little bit stream friendlier. So I added a new... Okay, so first of all, the remove... Because basically what was happening was it would remove the background image and re-add it. And the problem was the adding of the background image was an asynchronous operation. I think we can look at that here briefly. This is line in the 140s. Yeah, so there's an await here. And basically what happened was this was called multiple times, which a lot of things are, because, for example, initially it loads up a blank puzzle, right? And then eventually when the puzzle light is there, it also loads that puzzle. And it might load it again when the progress data is updated. So it might load 3 puzzles during the loading process, right? And that shouldn't be a problem as long as the loading is efficient and fast. So a blank puzzle shouldn't take very long to load, right? But basically what happened was that loading the remote, and obviously it's loading the actual puzzle multiple times as well, potentially. And that's something I need to fix, but it's easier to run it that way. But basically what was happening was because it was loading the remote URL asynchronously, it could hit this multiple times before it make this assignment, because this assignment here gates it, right? Because it checks, oh, if we have this, then we just skip out. But this assignment wouldn't actually happen until this await was finished, right? So it was starting multiple of these, and it was just recalculating these numbers based on the wrong information, with or without the puzzle loaded, etc., right? So what I was doing now is I was saying, okay, let me set the URL to what we're loading. And to be honest, if I'm not using this for anything else, yeah. And then I'm basically saying, oh, if the new image we're loading is the same as the image we have already loaded, then we're not going to reload. So it doesn't load the same image multiple times, right? And I decided to do it on the source URL, not on the final URL, because this one actually creates a local URL, a local blob URL, and that's asynchronous, right? So we wouldn't have that URL before the loading of the image. And what this does is basically tries to load the image to make sure we're actually getting an image, making sure it's an image type so people aren't doing weird code injections, things and stuff like that, right? So that's really all we're doing. And then we're delaying like we're saying, okay, if we're not the same image, then we're doing like a reset and a reload. So in that respect, this is actually relatively simple. And then here, these are just notes. It should have been part of the markdown. Comments regarding markdown support. All right. And then this is an actual feature. As minor as it is, it's a bug fix. So we're going to do that with a proper version bump, right? I'm just going to do the minor. Just to have a clean slate. So it's going to be a minor version bump, and the version number will be version 0600. Wow. All right. Fixed background image loader. All right. I'm not going to do a separate test of this. So now we have a clean repo that we can mess around with again. So let's just close all these files. Well, I'm almost unfolding all the tabs here. All right. So now this we don't need anymore. Although I'm going to keep that open for testing later when we do a deploy. So now we want to look at this outline stuff. Now the outline is a setting. Now, I don't know if that's implemented as a separate sort of plugin feature, or if this was like earlier and basically a native feature. Like some of the earliest features were quote unquote native. Let me just see. I'm just looking for the file. If I don't find it here, we might have to reverse engineer it from the settings dialog to find where actually it's done. But it's probably as simple as adding some CSS classes, maybe. So let's just search for outlines on elements. So that'll get us the setting. So we'll have outlines on elements, and then we have digit outlines. And digit outlines, yeah, I think that's one of the early pure sort of settings. All right. So there aren't that many references, right? So we have Sudoku bed colors, which are basically where all the colors are defined. And we have this. And the stroke here, which is in colors, which isn't great. Okay. Okay. So what we currently have is we have this outline filter getting added. And this one is a filter URL hashtag outline filter, which I'm guessing is part of the CSS. Outline filter URL, outline filter dark. Yeah, we have that for dark mode and for regular. If I get rid of the hash. Okay, so that's actually predefined here, which isn't great. So this is a raw feature, like it's not a custom sort of plugin feature. All right, so what I think I'm gonna do first is I'm gonna add a complete separate feature for one or the other, or maybe for both, and then just get rid of the original one for now. And then ultimately we decide if we want, I mean, for now the easiest thing is to just split it into two separate settings, but ultimately it might have to be a tri-value settings or something. I don't know. So let me see. Gotta fit this on the screen a little bit. So we have outlines on elements here. So let's add digit outlines, outlines on digits. On digits, let's actually call it that. Outlines on digits, and then we'll have outlines, lines on, so it's really on arrows and lines. For now. So if I do this, so that should add those, those settings should just appear in here now. Outlines on digits, outlines on off, outlines on digits on off. Okay, so then we're gonna look at the other code that uses that. So we have digit outlines, which get toggled. Don't need to worry about these. These are basically just the presets. Okay, so basically what the system does internally is, by default, any setting that gets toggled is added as a class, as a CSS class. So it's this is basically a codeless feature because it just works on CSS styles, right? So this doesn't affect the digits, so we don't even have to think about that. And then digit outlines here. It lives here. So we have a color for puzzle digit outlines. All right, digit outlines. And I think this is the only thing where something happens for the digits. Setting text stroke width, right? So instead of setting digit outlines, this is on, and let's move this down here for a sec. So now this is outlines on digits. Oh, I can't select. Double clicking here seems to include the dash. We'll do that. So if I refresh this now, and then say outlines on digits, and I can see that behind the dialog. Let's also put a 3. Whoops, put a 3 here. Center marks and corner marks. And if I now say outlines on digits, we can see these coming on, but the lines aren't. And if I disable that and put this on, we have nothing. So now we got to look in all the other places where digit outlines happens. And that is for the color. Puzzle digit outlines. Why? I guess that's light mode and dark mode, I imagine. I think the outlines for the digits isn't specified here. Let's change something. If we go dark mode, which by the way is still considered alpha because I've not officially finished it. We get dark outlines for this and dark outline for that. So the color is automatically adjusted. Okay. Oop. So then we basically just have to replicate some of these. So let's see what we got. We have the outline filter getting enabled or disabled, which is happening here. So I'm going to clone this for the digits on outlines. Now the question is, yeah, no, if I have them as separate settings, I don't actually have to worry about having like a separate handling of when both are enabled. They should just work independently. Okay. And then on here, we now have this color. We're just going to duplicate that for our new setting name. And for dark mode as well. Here. And then digit outline filter, I think, is not part of it. We have the stroke. Stroke puzzle digit outlines. Digit outlines. Stroke puzzle digit outlines. Okay, now I get it. Those are the colors that I defined. But we want to use the same color, I think. So instead of digit outlines, we're probably just going to... given outlines is separate. Given outlines. Ooh, wait. Where's this being used? Ooh, I hope this is not getting more complicated. I think the given outlines isn't actually used anywhere. It's a risk, but I'm tempted to deprecate this with a comment for now. And then instead of digit outlines, outlines on lines. I think we can just call this puzzle outlines as a color. Like this. Right. And then the other one was... So we have given outlines here as well. I don't think it's used anywhere. And then we'll just have this just outlines. Digit outlines becomes outlines. Digit outlines becomes outlines. And then we have, oops, we'll change this. No. We'll change this to outlines. Like that. And then I think we can just remove it for now. Just remove that. Wait. What was that? Yeah. That. And now if I search for digit outlines, which was the original settings name, it'll disappear from these places. Now the other issue is the default values will change. Okay, so now here I'm seeing the outlines on the elements already. Don't see it on the yellow very much because the white on the yellow doesn't stand out very much. So outlines on, arrows, lines on, off. I see it definitely. This still works. And then this also works. Why does that also work? I thought, oh, maybe because I didn't refresh. Digit outlines shouldn't be used anywhere anymore. Ah, no, because I still have it here. So if I get rid of that, right. So now that setting shouldn't do anything anymore. Oh, it still does. Where is this still being used? Ah, yeah, okay. Last place. And now, finally, toggling this isn't doing anything. This does the digits. Okay. The only annoying thing is that obviously people who want both have to change both. But that's not like the worst thing in the world. Okay. So that's relatively clean. So the only thing now left is to deal with the default settings. So we have digit outlines here. So instead of digit outlines, there should be outlines on digits and outlines on lines. And then the other one is here. I'm just gonna copy this. Digit outlines. Outlines on digits, digits outlines. Okay, so now digit outlines string should only exist here. And if we remove that, it won't exist anywhere anymore. Okay, and this shouldn't just blow up. What is this? Fail F. Uh-oh. Is that some debugging I've left in there? Oh, yes. I forgot. Oops. Part of some optimizations, I added a check about replay data being the same, like to compare two objects, and I have a generic object comparison thing in here, and apparently I left a lot of console log stuff in here. Probably when I was testing it. So I can just do this. This, and this. Oh my god, I must have been in the middle of testing this during the last stream. Whoops. And now I just pushed it in because I thought I only had... that's the danger when you work on multiple things at the same time. Because this file also has the markdown stuff in it. That's not great. Let me have a quick look at the change history here from wherever it was here. So that was already from the change I pushed earlier here. So the mistake had already gone in. Oops. And this is also version. Okay. Well, I don't think this is a fix worthy of a separate versioning. But it is a fix of separate checking. Remove debug logging. Sorry, there's dog hair on my keyboard. All right. Now we can review the new changes. So out of 1 becomes 2, 1 becomes 2. This one is just renamed. And then here, We get rid of given outlines. I think I'm just going to remove those instead of commenting in them out. So that's just a remove. And there's another remove up here. What is... Something is hitting something. Unfortunately, there's a lot of bouncy things happening. Do you guys hear this? Does this come through the microphone? I don't know what it is, but there's something that's vibrating because my desk is relatively lightweight and everything is kind of like springy. All right, let me know if there's some weird noises when I'm moving. All right, so we've renamed that. Outlines on digits, outlines on digits. Digit outlines becomes outlines because that's just a color, generic for all outlines. Outlines. Given outlines is gone. Digit outlines becomes outlines. Outlines on lines. Digit outlines becomes outlines on lines. We have new defaults and we have the settings themselves. All right. I think that I don't even think that needs like very thorough testing because it's really just the colors here. The one thing I don't know is if it's going to crap its pants with existing settings. That's the only problem. People will have to change their settings again because they're now different. That's a little bit annoying. Do I want to have code that detects previous settings and imports them? Ultimately, I always wanted that, but since this is a quote-unquote codeless feature, I don't want to add code just to do that. All right, so it's just in my ears then. So I don't really want to add code here that will... It means that people's default settings, like people who have that setting set one way or another, it might get reset to the new defaults because it doesn't. The old setting is going away, right? And there's some people who might be very annoyed by this because they might be, recording a video or something, and they might not remember what the setting was. But there isn't too much I can do about that. And I think by default, these settings are on, I think. If I go into an incognito window, and then I'll do something like this. No, by default, they're off. Okay, so it should be less impactful then, because the defaults are off. Yeah, which I think is the preferred way of doing this. All right, I think we're gonna have to do another minor bump then. And we have another labeled feature, and we're already up to 601. Split element outline settings. Bing, 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 bong. There we go. Now the other thing, well, now this should get deployed to beta and tested, and I haven't done a deploy to beta in a while, so let's do that right away. I think we need to do this from here. Right. I need a colorful test puzzle. I think on the homepage, one of the test puzzles has background colors. This one. Unfortunately, it's also a really old puzzle, so it doesn't have like modern conveniences such as titles and rules and stuff, or even solution checking. And this was a Simon video, so it's probably not trivial either, but let's give it a try. So I'm guessing these are our, little killers, right? So we have ones in these. So if this was a 1, these 3 would be 25. So that can't be a 1. If this was a 1, these would have to be 24. This could be a 1. So these 27 cages can't have a 1. Can't have a, so this can be at most 24. 24, so it could be a 2. 25. If this is a 1, 24. Okay, so the 1 could be here, here. 25. This could have a 1 in it. That could have a 1 in it. 18. Not a big deal. And then the 25 also could have a 1 in it. Okay, so we only have that limitations on this one. So the fact that this can be a 3 means these can't have 5s in them, right? So 3 plus 1 is 4. So 1, 4, 3 works. And no limitations here because that can be as low as a 2. So we can have 1, 2, and a 5, right? Now, if this is a 2, this is exactly a 7, 8, 9. Now, okay, so this means these 3 can't be, you know, so we got to take this as a whole, right? So the most these can be is double 9, which is 18, right? So if we add these up, it's 25 plus 26. It's 51. Minus 18 is 41. Minus 8 is 33. 33. And then these 4 at most can be 30. Right? 6, 7, 8, 9. But these can be 9s again. Oh, if we put 9s in these, we can't have 9s again in here. So at most we can have 2 9s and 2 8s. Because we've got a 9 here, 8 here, and an 8 here. So these 6, these are, wait. One sec. So the maximum is, if this is a 9 and an 8, and then we can have a 9, 8, 7, 6 in here. So 9, 8, 7, 6 is 30, plus 9, 8, plus 17 is 30, is 47. So 47. So these 2 can be at most, no, at minimum have to be 4? Wait, 47, right? This is 51, 47, that's 4, a difference of 4. So the most is, so the smallest these can be is 4. So the highest this can be is a 4. So this can't be a 1, 2 pair. So at least it has to be a 1, 3. But of course, you know, if this is a 1, it's not a big deal. Does that mean this can't be a 2? No, it doesn't mean that at all. The limit is on the other side. It just means this can't be very high because we can't push both of these very low. And our limitation here is bigger, so we should be looking at this one first. So we have, because we can have a 9 here, 9, 8, 7, 6, 9, 7, 6, 9, 8. So 6 and 8, 9 plus 8, 9. So we have 30. So these are 30 plus 17 is 47. 47. So these 2 are minimum 5. Minimum 5. So it can't be a 1, minimum 5. So this is at most a 3. But you know, if this is 4 or 5, it's much better for us, basically. I wonder if we have similar relationships down here with these cages, for example. Like a 12, for example, a 12 cage, 1, 3, 4, 5 is 13. So it has a 1 and a 2 in it. So we have a 1 and a 2 in these. 24. 24 doesn't necessarily have a 9 in it, right? It has a 9 or an 8 in it. 27 probably has a 9 in it, yes. So there's a 9 in here. There's a 9 in here. There's a 9 or an 8 here, and 9 or an 8 here. What? So these are 30 again. At most. But we can have a 9 here, 9 here, 9 here, 9 here, no problemo. And we could go as low as 8 and 6. On these, though, 8 and 7. But it could be 9, 8 here, 9, 8 here, so because they're all in separate cages. This can't be a 1. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. That can't be a 1. This can't be a 6. 1, 2, 3, 4, 5, 6. I'm trying to see if we got anything here. Ah, wait. Okay, these can't be 1s. Because we have 1 here and a 1 here. So the 1 is here. Can this have a 1 in it? Yes, just. This can't be a 6 then. So because this is 2, 3, so the highest this can be is a 4. Ah, what was our limit here? This was the max 4, max 3, so the max here is 5. Does the fact that this is a 9 make any difference? No, not at all. Most this can be a 5. Right, because then these two can be 4. Well, these two could be... It can't be 3. Also 4. 5. I don't know. I'm not sure. Let me do the same math again. We have 30 plus 17 is 47. These are 50. So these two can be 3, which means this can be a 6. Yeah, I know. Okay. The situation here is a little different. Now I'm wondering if the fact that there's a 2 in here... I mean, these don't have to have a 2 in them. Neither do these. Can I force a 1, 2, 4 up here? Yes. So this can't be a 5, because if that's a 5, this won't have a valid value. So that can't be a 5. 1, 2, 3. 1, 2, 3. 3, 6, 4, 5. We have a 5 here. We could still have a 4 in one of these. Is that an issue? Can we have a 4 in these at all? If this is a 1 or 2, we could have a 4 in here because we could have 1, 4, 5, and then this can be a 2, for example. Alright. We have 5 digits of 6 or less here. That's not super useful just yet. These are really big. I'm just seeing that's 44, which means this is 1 less than the sum of these two. The minimum of these are 3, so that can be 2 at the smallest. Not super surprising. I wonder if a stomach ring came into this puzzle as well. I'm also realizing I'm supposed to be testing the outlines, so let's enable them. This should also affect these lines, I think. Oh, I don't know actually. Does that affect these? Maybe not. Okay, we definitely have outlines here. And not on this line. Okay. I don't know how I feel about that. But it is what it is. That's not something I'm changing today. No. I was going to say, do we have the same sum of these? But because this is an 18, this can just be a 1. And then this can be 7, 8, 9. I mean, we do have a limitation on how many big digits we can stuff in here. Like, similar to this, like these 4 can be at most 30. While this together is 20, 50, 52. So these are 30. 52 minus 30 is 20. 52, right? 22. So these are 22. Oh, wait. If these are 22, these two together have to be at least 22 minus 17 is 5, because this can be 8, 9 at the most. So these have to be at least 5. 22, 5. I wonder if we have a similar relationship with the other ones as well. These have to be at least 5. 8 plus 8 is 16, at least 5. So these can be at most 11. I wonder if this is sort of a circular dependency. Now I kind of have to go ring around the rosy over and over and over, you know. I mean, 25 plus 25, these are 30. So these are 20. These are 20 minimum. while these at most are 7. So these are minimum 13. Wait, is that true? At most, these can be 30, right? 6, 7, 8, 9 is 30. These together are 50. So if we make these maximum and we take 30 out, then these are 20. But the most, these can be 7. So these are at least 13. So these can't be 1. So these are at least 13. So 4 is the lowest value for these. I don't think that can ever be a 4. But 4 and 3. 4 and 3 doesn't work. The lowest this can be is a 5. We can have a 4 and a 5. So it can't be a 4. And I guess the same is true for this. This can never be a 4 because then it'll go with a 2 here, and then that's 6. And then we need to have 19 and 2, which we can't. 5 and 4 is 9, and 16 and 2, that does work. So is this better or worse? 30, 52, it's 22 here. 22 minus 9 is 13. No, we have the same thing. It's just that these can be slightly bigger because they can go up to 5 here somehow. I don't recognize why. But if this is a 4, these two would be 9, and we'd need 18 and 2, which we can. So this is also a 5. But then it'll still be a 9, which still would force it to 18. So it can't be a 5 even. And then here, this is a 4, 9, 16. That does work. It does work. Why didn't it not work here? Oh, because that couldn't be as high as a 5. All right. I mean, it does make sense because this is our 3, 4, 5, and then these are all 6, 7, 8, 9. So we have a kind of a high-low theme going on here. I don't remember this, like I have a vague memory of this video existing just because it is as one of the sample puzzles, right? So we have one from 3, 4, 5, and one. So these all are 3, 4, 5, 6, 7, 8, 9, which I guess makes sense because 1 and 2 is taken over here. These can have 1 and 2. These can't have 1 and 2 at all. So 27 is kind of special in that sense. It can't have a 1 or a 2 in it. This can't be a 1, so we know, yeah, okay, we know the 1 is down here. What do we know about the 2? Could this be a 2? Because this could be a 1, 3, 4, I suppose. So this could technically be a 2. This one, we don't know if it has a 1 in it for sure. Ah, but wait, no, this could have a 1 in it. God damn it. I mean, it couldn't be here. But there could be a 1 here. And then it could be a 1 here and a 1 here. So that's a possibility. I wonder if the fact that these can't be 1 is telling something about the sum of this box. Because that means these are at least 2, 3, and they can't be 2, 3. Like, what is the maximum value of these? Like, if these were... Or maybe here's the more constrained version, right? This is a 6. No, wait, the maximum for these would be the minimum for these, right? 1, 2, 3, 4. So that's our first digit. So the others are all 5, 6, 7, 8, 9. So these are 5, 6, 7, 8, 9. So it means in theory, the minimum of these two is 11. No, we were looking for the maximum for these. So the minimum of these is 11, which means these are 52 minus 11, 41. Which means these 3 would be 4, but they can't be 4. So these can't be 11, but they can obviously be much bigger. But we could technically give them a minimum value, right? I hope I haven't bitten up too much, more than I can chew. Because the sort of quote-unquote longer Simon puzzles aren't usually my comfort zone. What is this? This is 39. 39, so 6. So this has to be 6 smaller than these two together. But I think we know that this has to be a fairly big number, right? It could be small. If this is a 6, we could have a 2 here. I mean, not a 2, but it could be as small as a 3, right? We've got 6, 3, and then 7, 9 here. But this has to be a 5. The smallest this can be is, this is a 6, this could be a 2. So 2 and 5 is 7. 7 plus 12 is 17. 37. 44. Oh, that wouldn't be big enough. Wait, what? This is a 3. 24. 24, 36. And then these two would have to be 9. Okay, I don't see a way of making that work better. What is the relation? So, these are 39. So we need 6 more. So, if you subtract 3, let's say, 39, it'll be 36. This is a 3. Then this is 24. 36, and then these two would have to be 9. So these are 6 more than this. If this is a 9, these two would, if this is a 9, then this is 18, 20, 30. Then these would have to be 15 if this is a 9. So the most these can be 15, so it's a lower limit. At most these two can be 15. But it doesn't stop us from reaching 30 on these two. But maybe the problem is different up here. Although here the numbers are different, right? 14 plus 23 is 37. So 37, we need 8 more. We take this out, so we need 8 plus this. So if this is a 9, we need 17 in here. I don't see how that helps us. What about if I add the 14 in, right? Because this is 52, 56, 66. And we know this whole thing is 90. So 66, 90 minus 630 minus 6 is 24. So these 6 are 24, which doesn't seem like a big problem. Doesn't seem like a big problem at all. 24, because the 14 is relatively small. I mean, here the 20 is bigger, but then the 18 is really small. Let's see what the ratio though is. 46, 56, 64. So it's bigger, but not by much. 50 plus 12 is 62. 50 is 62 as well. I'm curious if that says something about the corners, that they can't be very large. Because we know already that these are relatively large. Because these have to be 50, right? So these have to be relatively large. 50. The max these could be is 10. The max these are 30, so the smallest these can be is 20. Well, that being said, if this is the max, we can't have them all be max, because then we're running into problems in the corners, right? So we have 5 opportunities for small numbers, which is 15. 1, 2, 3, 4, 5. And then these would add up to 30, which would be the maximum, right? But if we do this all the way around, is that a problem? Not really. It just means that the corners are small. But here we know the corner can't be a 1, but it doesn't need to be. We have plenty of other places where we can sneak in these smaller numbers, right? I remember this as being a coloring puzzle high-low as well. So, I mean, we know this is 6, 7, 8, and there's another 20. There was another 27 somewhere, wasn't there? There are these. But we haven't limited them to the high digits yet. I mean, we know these can't be too small because we already have a very small here. And especially on this one. 1, 2, 4. Like, we can't have any of these. Right? And we can't have a second 3, so it's not this configuration. So but that's our first digit, and then the rest is 5, 6, 7, 8. I want to know what's... I think it's something on the microphone itself. Maybe, because I have these weights on here, maybe the weights themselves are wobbling. Or maybe the weights aren't heavy enough. and the whole microphone is actually... I need to add some foam in between those weights and stuff. All right. It's quite janky, actually. So janky. 3, 4, 5, 6, 7, 8, 9. But we know there's a 9 in one of these. So anything that sees all 3 can't be a 9. Like this obviously can't be a 9. 6, 7, 8, 9. 3 from 6, 7, 8, 9. But this could still be any of those except 9. Could be still from 6, 7, 8. This is a 6. Then this could still be 3, 7, 8, 9 or whatever. 3, 4, 5. This 3, 4, 5. I wonder if there's a correlation. I'm just thinking, like, is this digit limited? Like, can't this be maybe one of the high ones? Like, if this was a 6, this couldn't have a 6 in it. But we have, it could be 3, 7, 8, 9. But I'm saying, okay, if this is a 6, we have a 3. But the 3 could be here and here. And then we don't have a problem at all. I'm also now thinking about the horizontal and vertical lines. Because these are all relatively large-ish digits. Like, where can we put things like 1s? But we have so many places to hide them. Hey, babe. Yeah, also, I'm just looking, because we have outlines on the V shape here. So if I change the outlines on, let's say, the arrows and lines. Okay, that disables it for the outline, but not for the digits. If we do it the other way around... Oh, that's the wrong... Yeah, except in this puzzle specifically, I think I want the outlines on the digits. So we put the outlines on the digits back on. And that works. Alright. I guess I really kind of want to solve this puzzle now. And I want to solve it without, like, looking things up, because I feel like I've not been solving puzzles long enough that I should be able to kind of get my head around it. And I'm seeing a lot of the patterns, but I'm not quite there. And I feel like I have to do, like, chaining dependencies, right? Because this clearly interacts with these, which interacts with these, right? So let's say if this one is high, to make this one low, but now this can't be low, and it kind of goes around, round, and it affects these, right? Because if these have to be high, then this has to be low. Like, for example, if this is a 6, then these two would be 3. Which just works, right? 47, so 47 minus 30 is 17, and this can be an 8, 9, which exactly just works out. But we also have these edge boxes where these are limited by what they can be due to this being relatively low and this being relatively high. Although being low and high, like that's 39 in sum, that's 37, that's 44. This is kind of one of the extreme ones, but then here we have an 18 cage. Which is probably why we have that 18 cage there, because otherwise it wouldn't work. Like this one, again, this is a 27. Yeah, for example, we know this can't be a 9, because it would take a 9 out of here and push 9 in both of these, and they can't both be 9, right? And we know both of these cages must have a 9, so we know this can't be a 9, but that's not a huge limitation, is it? Now, if this is a 9, it puts a 9 here, and then forces a 9 here. Could we not have a 9 in any of these? That's an interesting question. Actually, is it interesting? The other question is, does this always have to be 30, or can we have this as a 5? I'm pretty sure it needs to include a 9. And that's probably something we could say, right? Because if this is 5, 6, 7, 8, that's 11, 18, plus 8, it's 26, right? And then we max these, plus 17, 26 plus 17 is 30, 43, and we need to get a 52, 43, 43, 7, 9, and these can be 9, right? So we know there's a 9 here. And I wouldn't be surprised if we can make the same statement about this one. So if this doesn't have a 9 in it, so again, 11, 18, 26, so it's 26 plus 17. And we know why this can't be 9, 9, right? So, oh wait, it could be 9, 9. If we're excluding 9s from there, these could be 9, 9. Let's do it on this one again. If these are 26 plus 9, 9 plus 18, 26, 36. 36 plus 8, 44. 52 minus 44. I mean, 50 minus 10, 12. Minus 4 is 8. Yeah, these can't be 8. So we still have the 9 in here. Now here, these would be 7. This could be a 1. Because these are 1 less, because we have a 26 here. So here we could, in theory, have no 9 here, but then we'd have double 9 here. Okay. Now, the fact that we have a 9 force here, does that tell us anything? Because I thought we kind of knew that. And I think this one must have a 9 in it, and this one may or may not have a 9. I'm just saying, does this have to be a 9? I'm sorry, do we still have to have a 9 in one of these? Because, so the minimum this can be now is 5, 6, 7, 9, right? So 11, 18 plus 9 is 27. Now, if we don't have a 9 in here, it would be 15. And I just said these were 27, right? So 27 plus 15, 27, 37, 42. The maximum of these is 42 is 7, 49, which isn't enough. So we know there's at least one 9 in here. And we know there can't be 2 9s because then we can't have a 9 in here. So there's one 9 in one of these, which means this can't be a 9, but the less than equal sign tells us that as well. Let's figure out what is the minimum of the other digits. So one of these is a 9. So we have the maximum this can be 30 plus 9 is 39 plus 7, maximum for these is 39 plus 7 is 46, and we need 52. So 6. So we can't have a 5 in here anymore. So 6 is the smallest we can have in these. But I think we can still have a 5 here. All right, so that's interesting. So this one could have a 5 here, but these, yeah. This one could be like 4, 5. All right. But now we have a 6, 7, 8, 9 in already a bunch of cells here. And do they see each other? This one, I think this could be the same as any of these, right? This could be a 9. Yeah, if one of these is a 9, then this has to be a 9, right? So in fact, this one of these has to be in here. Like this one has to be here if it's a 9. And if it's not a 9, could it be here? That's the question I have for myself. Because the other thing is, right, the digits 1 through 4 aren't in these. And they can't all be in here. So one of these has to be from 1 through 4. We also know we can have a 5 in here. Can we not have an 8 in here? So can it be 5, 6, 7, 9? Like, could one of these be a 8? Like, we know it can't be a 9. So let's do the same thing for it. So 5, 6, 7, 8. So that's 11, 18, 9 is 27. So 27 plus 7 is 34. 34. 52 minus 34 is 22 minus 4 is 18. And they can't be, so they can't be 9. So there's an 8 in here as well. So now these can't be 8 or 9. So now we know the minimum is 5, 6, 8, 9. And I think that's where we're hitting our limits, right? So 5, 6, 8, 9, that's 11, 20, 28. 28 plus 7 is 35. So 17, and this is what gives us the 8, 9 pair. Now, that is if this is a 1. Can we make this a 3 now? Because if this is a 3, then these two sum to 5. These, so that would be 5, 35, 52 minus 35 is 22 minus 5 is 17. That'll be 8, 9 here. Okay. Now the problem is I think this is the most constrained box because it has that 27 here. This is much less constrained because we have both a 9 here, which makes these digits potentially larger, and two 25s. This one is the second most constrained box, I think. So for example, I don't think we can do without a 9 in these. Let's just double check. 5, 6, 7, 8. So the 18 plus 8 is 26. Plus 7 is 33. 33 plus... Could it be double 9 now? Yes. 33 plus 18 is 43. 51. And that's... So it could be double 9, huh? But if this is double 9... This... Okay, so it can't be double 9. So we're one short then. So we know there's a 9 in these as well. Does that tell anything about this one? Because if this is a 9, puts a 9 here, takes a 9 out of there, and then... Yeah, I guess there's no real problem with that. Does 14 can't have a 9 in it. Oh, wait, 14 can't have an but this one could have the 9 in it. Now, if this doesn't have the 9 in it, i.e. the 9 is here, then this might force a relatively large digit here. Is that a problem? 14. So 45 minus 14 is 31. 31, the smallest this can be is a 1. 31 minus 22 is 31 is 11, minus 2 is 9. So these would add up to 9. It's not that small. But it pushes this pretty high up, and these are all pretty high up. Especially on these two. Although one of them could be a 3. I mean, it could be 3, 4 really. Although if one of these is a 3, if this is a 7, 8, 9, this forces this down to a 6, and this down to a 5, which I'm not sure if that's possible. 8 plus 60, sorry, plus 30, 38. 50 minus 38 is 12. So the lowest one of these could be is a 3. There's some second, there's a, like a, I feel like I've gone 2 layers deep, and I think I'm missing the 3rd layer. And I'm still not pushing something, like I'm not min-maxing, pushing a min-max value around the grid, where our bottom right is the weakest because of this 18 cage, right? And this is our strongest corner. But I've seen patterns like this before. And this is the sort of thing I'd love to like learn about in terms of setting, you know. Also the fact that these two are the same, and these two, well, actually, no, we have 25, 25, 25, 27, 25, 26. But these two, 27, 12, 27, 12 combos are the same. And then here we have a relatively large combo between these two. Because the smallest this can have in it is a 7. But it still leaves 8, 9 to go into these. And this doesn't need that big of a digit. I'm also trying to see if I can say something about these. Because obviously, yes, it forces the 1 in these 3. But then the rest, there's 2 ways to form 7 without a 1, right? So it's, 2, 5, 3, 4. So the other one of that is available for the corners, but also it could be going to some of these. I'm trying to think if I should go back to programming or if I should try to stick with this and try to solve it. I wasn't planning on doing a solve video. I'm not that good of a solver, but it might still be fun. Problem is my mind is just sort of bouncing around, so I'm not sure if I'm working the problem or if I'm just sort of waiting for some lucky something to hit me. We also looked at these before, right? We said, okay, if this is 30, then 27 plus 25, which is 52 minus 30 is 22. So these would have to be 22. The highest these two can be is 9. 22 minus 9 is 13. So these have to be at least 13. And I think something similar applies to these. The highest these two can be a 7. Right? 30 plus 7 is 37. 50 minus 37 is 13. I mean, we've already eliminated 3 from these. These are all from 1, 2, 3, 4, 5, 6. Which means only one more of these can be from under 6, or 6 or less. And then the others, like, I was just thinking, like, this can't be 1 and 2. So one of 1 and 2 has to be here. Can this be from 1 and 2? Yes, because this could be a 4. Could have one from 1 and 2 here. The other from 1 and 2 here. So this could be, let's say, 1, 3, 6, 4. And then this could be 2. But I feel like we also have an issue then here, because if this is a 2, then the 2 goes here, and then... In fact, maybe this is the harder problem, right? This can't be a 6, because it can't be 1, 2, 3, because it'll clash with this. Can it be 1 and 2? Can this be not from 1, 2? If this is 1, 2, this is a 3, then this is just a high number. But if this is a high number, it pushes these low, which could be a problem. Interesting. 3, 4, or 5. This needs a 3, a 4, or 5. 3, 4, 5. Yeah, it doesn't. I was wondering if I could push the low digit out, but I don't actually can do that because this is one of the high digits, so these can't all be super high. There's no 2 here. Can I eliminate 2 from here? No, I don't think so. So this could be 1, 3, 4. This could be 2. This could be 5. And 6, 7, 8, 9. Like they like to be high anyways, right? I don't think the 18kh helps us in any way because it's so middling. And this digit being relatively slow. This one, 1, 2, 4. So that 1, 2, 4 here. 5, 6, 7, 8, 9. 5, 6, 7, 8, 9. Aw, thanks, Keith. Feel free to help. Help. Like I keep thinking, okay, usually you start with the most constrained thing. So should I keep looking here? But if I get stuck, should I look somewhere else? Because we also have this one, which is almost as constrained. But normally you go from the most constrained, and then it kind of cascades down, right? Ciao, guys. Have a good walk. So I don't think I can eliminate a 5 from these two yet. So it's not the most constrained, which means there's like some secondary layer. And I'm wondering if it's related to these being relatively large all the way around. Because like there's nothing stopping these two from being 1, 2, for example. These being 3, 4. And then these could be all tall, big numbers, tall numbers. Big numbers, Simon never gets stuck like this. He's got tools in his toolbox. These 25 cages. What's the... Like, these can't be 1s because then the others would be 7, 8, 9, and this can't be a 7, 9. If I max 5, 8, 9, right? Like, I'm trying to see what the minimum of these is, right? So if these are 5, 8, 9, that's 17 plus 5, that's 22. So 3 is the bare, like, the mathematical minimum. But I think there's other reasons why we can't have a 3 in here. Because if I have a 3 in here, then the max of the others is 6, 7, 8, 9, which is 24. So it's 27. So these would add up to 27. And then these would have to be 25. While these can be only 9. 25 minus 9 is 16. Which is actually no problem at all. Darn. I thought I had something there. 16. It just means there's a 9 in one of these. Yeah, it means we can have fairly low digits in here. Now they can't all be low, right? Like we can have 2 low digits here. But that's fine. What am I missing? And down here is, I think, even less constrained, right? Like if this is a 6, 8, 9, 17 plus 6 is 23, and these can be as low as 2. So We just can't have a 1 in these. But they can be as low as 2. This can't be a 2. But they can be so low. I mean, obviously, just one of them can be really low. Like, if this is 6 and that's a 4, that's 10. Plus 17. 8, 9, i.e. Plus 2. 10 plus 17 is 27. 29. 29 plus 7 is 36. And we need 50. 36. So these are 14, which is not a problem. We said this can't be a 6, because this can't be a 1, 2, 3. 4, 5, 6. 7, 8, 9. I suspect these can't be very, very small, but suspicion isn't super helpful. Ah, wait, there's no 1 here. Ah, but it's just can we force the 1 in here? But no, because the 1 could be here. This is a 2. That'd be a 1. That'd be a 4. Then this could be a 5. This could be a 4. Yeah, that's not helpful. 1, 2, 3, 4, 5, 6. Which means only one more of these can be 6 or under, and the others are 7, 8, 9. But yeah, we already know that these are all relatively high digits. I think we can't force the 7 into these, right? We can't. We could have a 5, 6, 8, 9 here. 5, 6, that's 11. 8, 9, that's 5, 6 plus 9 is 20. 28. 28 plus 7 is 35. 35. And then these would be 8, 9 for 17, yeah. So we can't get the 5 out of those. Well, that's annoying. And we can't even force an 8 into these because we have 1 less. It's constrained by 1 less. Can we do anything with this 14? No, we can't even force a 1 into it. 13, 2, 3, 4, 5. Yeah, 13 would force a 1. So, which is probably the reason why they did it. They managed to have an arrangement that's slightly less clear and less constrained. 1, 2, 4. The fact that what is the smallest these can be? 3, 5, which is 8. And then these would have to add up to 10, which could be 1 and 9. So it's no limitation at all. 8, 9, 17 plus 6 is 23. So this could be any of these could still be a 2. This is a 5. This would be a 1, 2 pair, which would force 1, 2 into these. Still, no problem, really. 3. If this is a 3, these would add up to 5. This could be 3, 4, 1. Yeah. Also, the fact that the 1s are here, like no 1 here. Oh wait, no. This could have a 1. You see, that's the problem. This could have a 1 in it. We already pushed the 1s. Push the 1s out of here. That's the only thing we've said. It's one limitation we have. No 1 in here, and I think we pushed like a 3 out of somewhere. This can't have a 1 in it. But it doesn't even force a 9 yet. Although I can probably force a 9 another way. If I can force a 9 here, knowing there's a 9 here, it would take a 9 out of here. 4, 6, 7, 8. Is there anything preventing this being from a 4, 6, 7, 8? I don't think so. Nothing that I can currently see. Ooh, GDC is here to save the day. You can't see the cage totals. My smartphone's going to. I'm not very good. There's a global math that makes the green digits in box 5. Global math. Let's think about that. I mean, I suspected something like that. Oh, I probably have to add up all the cages. You know what? let's use brain enhancement, i.e. notes. Let's add up all the reds. So we have 25 plus 27 plus 25 plus 26 plus 18 plus 25 plus 25 plus 25. So red is these, and I'm not even gonna bother. Okay, that's 196. Right. So that's red. Yeah, we're gonna do this. Let's do blue. Blue is 14 plus 12 plus 12 plus 20. And that's 24, 34, 38, 38, 58. And then green is 23 plus 27, which is 50, plus 27, which is 77, plus 24 is 97, is 101. I'm going to double check that. Yeah. So the total here is 196 plus 58 plus 101, which is 355. 355. And the normal total is, the total total is 9 times 45, right? The 45 kgs. So for a grand total is 405. White then is 50. So all the white squares add up to 50. Right. So these 5 are 15 minimum. These 3 are more than 6 times 3. But let's say if they were 6 times 4. So these are, let's say, if these all were 1, 2, 3 each, which they can't be, but if they were, that'd be 6 times 4. It's 24 plus 15, which is 15. Wait. 6 times 4 is 12. 24 plus 15, 34, 39. So we have 11 wiggle room. Right. You had 356. Let's double check. 14, 12, 12, 20 is 58. That's correct. Green. It's 23, 24, 27, 27. That's 101. That's correct. And then red is 25, 27, 25, 26, 18, 25, 25, 25. 196. Okay, no, I'm all right. I'm all right. I'm using computer-assisted mathematics. All right. What is the minimum of one of these? Because it can't be 1, 2, 3. It can only have one from 1, 2, and it can't be 1, 3, 4 because so it can't even have. It could have a 1 in here actually. I forgot that it has. So we want this to be a 1. But then we can't have 2 and 3 because 8, we can't have 1, 4, 5, right? So, so 1, 2, 4 is the smallest for these two. So these two, so that would be, so we have 15 in the middle, plus 7 in the upper 2 corners, so times 2. The smallest this one can be is 1, 3, 5, which is 8, right? And what is our leftover of that right now? What is our budget for these 3? So if this was 15 and this was 7 and this was 7 and this was 8, which is its minimum, i.e. 1 here. The funny thing is we can only have one of these being a 1. And since both of these have the 1 in it, it means that we can't have 1s in these. Which means one of these actually has to be a 9. So we can't have this be 7 and this be an 8. That's not possible, right? Which is kind of interesting. Which is probably where this min-maxing is going, right? So the smallest this is a 1, then this can't be a 1, then this, and it can't be a 2, 3, 4 either. It could be a 2, so 1, 3, 4, 2, 5, 6. 2, 5, 6. 2, 5, 6, that's huge. 2, 5, 6, that's 13. So 1, 3, 5, which is 8, plus 13. So wait, 8 plus 13, plus the 15 from the middle, plus the minimum in the upper left, which is a 7. And the minimum bottom left could be 1, 2, 2, 3, 4, 2, 1, 2, 5, which is 8, which is already too big. So I have a strong feeling that that actually fixes our arrangement of whites. We just have to figure out exactly in which way, right? Like, for example, if this was a 4, then these would have to be 3, 5, which is already way too high. So this can't be a 4. And probably the same is true for these, right? If this is a 4, we know this would be the 1. So this would be 2 and 3, except 1, 4, 4, 3, 5. 4, 3, 5 is 9, is 12. So wait a second. 50 minus 15 is 35 divided by 4. So the most these can average is 8.75, which isn't a lot. And we can probably calculate now by adding all of these things around. We can probably say, okay, let's ignore these, right? Calculate what the sum of these are, because we can add up these, but we don't. I mean, there's definitely min-maxing happening, right? In the ones where we have the 8s, if this isn't, like, only one of these can be a 1, and the one that isn't a 1 can't have a 1 on it, and it can't be 2, 3, 4. I feel like I'm so close. Hey, Apex, how are you doing? I'm trying to solve a puzzle that I should be able to solve. And without GDC's kind comment about the global sum, and I just didn't want to go there, but yeah, I was being lazy. But with that hint, I should be able to solve it. I'm trying to think. Okay, so the minimum, let's say on the 7. What if this is a 2? If this is a 2, then 3, 5 is the smallest. So 2, 3, 5 is already 10. So 10 plus 15 is 25. So we have 25 in 3 more boxes. And 25 divided by 3 is 8.3. So it's already pushed our maximums down. But we can now have a 1 here. But if we put a 1 here, then these two have to be 7 at best. Right? This, like, 1, 2, 4, 1, 3, 5. No, it can't be, right? Because of... And in fact, wait. If we do this... maybe that's easier. If we min-max these... Right? If I min-max these... And these... That's 5 times 15, which is 75, right? So that means these can add up to 25 at most. 25 at most, divided by 4, 25 divided by 4. So 6.24, 6.25 on average. Which isn't a lot, which means, like, if any of these are anything other than 1 or 2, we kind of already have a problem, right? So I suspect, and I'm tempted to just put them in there. I suspect these central ones, they all have to be 1 or 2. But can I prove it? Can I prove it? Okay, so if I take these, right? So we set at 75. So 60. So this would be 60. So I can now remove that 60 at minimum. Now if I remove 8 and 8, so 60 minus... Right, why is it 50? 15 times 4 is 60, right, 60. 60 minus 8, 52 minus 8, 44 minus 9, 36 minus 7, 29. So these would be 29. And we have a 35 budget because it's 50 for all the white cells and 15 minimum in the middle. It's 35. And I just said what? 30. What did I say? 25? Damn. 60. Okay, wait. It's 60 minus 8 minus 8 minus 9 minus 7 is 28. So these are 28. Minimum or maximum? Minimum? I guess so. 28 divided by 4 is 7. I mean, we said that already. The minimum of these is 7. This one is more than 7, so I'm guessing that balances out with this one. So the minimum of these two is 7. The minimum of this one is 135, which is 8. Which means now the minimum, the maximum on these is 6. Which does make sense because we can make it... Oh, yeah, we can make it 1, 5, and then 2, 3, 4. Yeah, but that implies they're all minimal. Which means they're all 1, 2, 3, 4, 5s. 1, 2, 3, 4, 5. Except in here where they can be 6s, I suppose. And here obviously they can't be 1, 2, 4 because we said they can be they have to be bigger. But it means these two can't be 1, 2, 4. This has to be a 1. And I'm guessing that has to be correct to some extent. So that's the 1. That's the 1. Now these can't be 5, 6. And this has to be a 5. Right. 5. This can't be a 1. So we have a 1 here. So now these have to be... Oh, they can't be 2, 3, 4 either. Is that where we're going with that? Because if this has a 1, then these are 7, 8, 9. 5. 8. So these two add up to 7. So it's either... This can't be a 4. 2, 5. This can be a 2. 2, 3. So we have a 3 here. 1. So what you said earlier, I guess, is proven out by that. So this needs a 1, 2, 3, 4, 5. Now, can't have a 5 in here. No 5 here. No 3 here. 2, 3, 4. So none of these can be 2, 3, 4. So this is 6, 7, 8, 9 now. This has to be quite small. No 5, no 5, no 5. 2, 4, 6, 7, 8, 9. This one now can't have a 1 in it. It's got a 2 and a 4 or a 4 in it. No 5. It's gonna have a 6 in it. This one can't have a 3 in it. It's gotta have a 2 or 4 in it. It could have a 1 over here. We don't know yet. This one is 1, 7, 8, 9. This one has a 4 or 5 in it, so it can't have a 2 in it. It can't have a 3 in it. It's got a 4 or 5 in it. Okay. This one we don't really have limitations on yet. This one can't have a 5 in it. It's got to have a 2 or 4 in it, so it can't have a 1 in it. 2 or 4. Can't have a 3 in it. Will have a 6 and an 8 in it. Okay. This one can't have a 5 in it because of this 5 seeing it all. It sees all. This 5 sees all. Alright, 2. Alright. 2, 4. This is an 8. So that means these can't be 3, 4, 5. So this is 6, 7, 8, 9. All right. So one of these has to be the small one, but this one can't have a 5 in it now. This one we don't know much about. This one can't have a 5 in it either. This one has a 9 and an 8 in it. One of which probably has to be... probably, but maybe not guaranteed yet. Don't know about this one yet. We have a 2, 4 down here. Oh, okay, so this is 6, 7, 8, 9 as well. So 3, 6, or 4, 5. That's a 9. So one of these, we have 9 plus the sum of 9, which is 2 digits adding up to 9. Wait a second. Wait, what? Ah, no, because 6 can be in here. Yes. 3, 6, or 4, 5. There's a little bit of interference here. Okay, so one of these is the one with the 2 in it, and the other one is the one with the 9 in it. Sorry, with the 4 in it. So both of them have 6 and 8. Which means one of these needs to be a 6 or an 8. No. They both need to be 6 and 8s, because we need a 6, 8 in this row and a 6 and an 8 in this row, because we need 2 6s and 2 8s. So this is a 6, 8 pair, which means this can't be 6, 8. Whoops. This was a 1, right? Which means there's a 1 here. I don't I don't know. This one can't have a 1 in it. Over here. This is 6, 7, 8, 9. Got a 1 here, 1 here. This one could have a 1 in it. This got to be larger. That's not helpful yet. 1 and a 2. 1, 2, 3, 4. We have a 3 here. This can't have 2, like it can't have a 3 and a 4. Yeah, so this is 6, 7, 8, 9. So these are all 6, 7, 8, 9s, and the 1 is either here or here. 6, 7, 8, 9. Can that still have a 5 here? I don't know. 1, 2, 3. 1, 2, 3, 4, 5, 6. No, because 6 is also... wait. 6 could be in here. It can't be here. So we can't have a 6 in here, which means we can't have a 3 in it. Which means we have to have a 3 here. Which means that can't be a 3. That's a 3. No, that means 3, 7, 8. So no 4. And no 6. No 3 here. No 3 here. This is a 1 or 2. So this needs to be a 1 or 2. Because they can't both be here now. We said no 6s here. So this can't be a 5. 2, 4, 5 makes sense. 3, 7, 8. 2, 4. Sorry, 3, 7, 8, 9. Yeah. So 6 is one of these and one of these. So we have 6 here and here. No 6 here, no 6 here. 6 here. This has to have a 7 or 9 in it. Fair enough. 2, 4, 6, 8. I'm just thinking if to force a 6, 8 in this area, like no, doesn't mean anything. 3. We can't have a 6 in here now. 7, 8, 9. So we have a 6 in one of these. We have no 1 in the middle. 1s go around the outside. 1s and 2s. Oh, Apex, go for it. I love backseating. I'm not good enough at these puzzles. 2, 3, 4, 5. So this is 6, 7, 8, 9. So 6 has to be in here. So this has got to have a 6 in it. So we have a 4 or 5. We have a 7. 4, 5, 6, 7, 8, 9. We have a 7 in one of these. 2, 4, 5 here, which means one of these needs to be a 5. Ah, we knew that already. Which means this can't be a 2, 4, or 5, but it could still be a 1. 2 from 6, 7, 8, 9. So it can't be this one, can't be this one. Could be this one. 7, 8, 6, 9, 6, 7. Definitely has a 1 in it now, which means this has to be a 1. Which means this can't have a 1 in it, and this never tried to. Which means there's a 1 here now. This is not a 1. We have a 1 here. So 1, 2, or 1, 4. And 6, 7, 8, 9. Ah, okay. Yeah, this is getting up there for me. Okay, one of these is a 6, because then we have a 6, 7, 9, so that can't be a 6. So we know now there's a 6 in here, which means we don't have a 3 in here. 2, 4, 1, 2, 3, 4, 5. So this is one of 1, 2, 3, 4, 5. This could still have a 1 in it as well. That's odd. Didn't expect that. Seems like a big cage for having a 1 in it, but there we are. All right. Well, can this be a 4? No. Because that's minimum here is 4. 4 and 1 is 5, so this could be as low as a 3, but it can't be a 4 anymore. In fact, this cage can't have a 4 in it at all. It's got 1 from 1 to 3. 5, 6, 7. It does have a 9 in it now, which means... Could this be a 9? Yes. And we know... we don't know, actually. But we know both of these cages have a 9 in it. So we know one of these is a 9. Which doesn't mean anything either. There's a 4 or 5. So 1, 7, 8, 9. No 1, no 5. 2, 3, 4, 6. It does have some small digits in there. In fact, it has 1 from 2, 3, 4 in here, which goes straight into this one. Let's see, that's 44, 45. So these two are the same digit, and they needs to be either here or here or here even. Okay, that's not useful. That's not very useful. Is there something this could be that would mess these up? No, not that I can see. Oh, there's a 3 in here now. Okay, so that's a 3, 7, 8. So no 6, no 5, no 4. So 3, 3. That can't be a 3. This, 3 has to be in here. 2, 4, 5. 5 has to be here. That can't be a 5 now. Okay, so now this one doesn't have a 5 in it. So we can get rid of this one. So 1, 2, 3. We're guaranteed a 9. 7, 8, 9. So 6 is one of these two now. Anything that sees both of them? No, not really. 3, 7, 8. Same as this one. That's curious, actually. Does that say anything about, like, 8? One of these has to have an 8 in it. Either here or here. One of these can't be an 8. But the 8 is in here. So that's not super specific. 1s here or here. No. Okay. 2s not limited. 2, 2, 4, 2, 4, 2, 4, 9. 2, 4, 5. 4 or 5, 6 and 7, 9 or 8. 6, 7, 8, 9. 6, 7, 9. Since both of them have a 9 in it, one of these has to be a 9. We know one of these has to be a 9, which means now neither this or this can be a 9. Which also means one of these has to be a 9, which means this can't have a 9. Now this can't have a 9 in it. Oh. That's interesting. And it has to have an 8 in it. And it can't have a 1 in it now, which means this has to have a 1 in it. And the 1 has to be here, which makes this a 2. Which puts a 2 here and a 1 here. No 2 here. Makes this a 3. which means this can't have, pressed the wrong one. It can't have a 3 in it now, which means this has to have a 3 in it, and precisely here, well, precisely. One of these is a 3. We have a 1 in here now. That can't be a 2 anymore. So this also now has a 7 in it, besides the 9. This has a 7 in it. So this has to be a 9 or 7, because if 9 and 7 were here, this wouldn't have a value. Now this is a 4, 2, 4. So this is now a 4, 6, 7, 8. So no 9. Ooh, no 9. Whoops. This can't be a 7. No 7 here. That's a 3. That's a 1 now. 1, 7, 8, 9. So no 6 here. So 6 goes here. 8 goes here. No 6 here. 4, 5. No 8. 3. Alright. 4, 5. Over here. That's a 9 now. That is a 9. This is a 6. So that goes, 8 goes here. 8 goes here, which means that's a 9. 8, 7, 9, 6, 9, 6, 9. And this now we need an 8. 7, 8, 6. Whoops, 7, 6. So this has a 6 in it, which means that can't be a 6, which means that can't be a 5. How does it limit it? Well, we know there's an 8 here, so that makes this a 9. The problem is I don't have the solution checker for this puzzle, so I'm gonna have to do some serious checking. I tend to make a lot of mistakes. Like, I'm not a very diligent solver. From early makes, row 2, column 2, row 2, column 8 minimized. 2, 2, 2, 8. Probably, I think I got to that in a roundabout way. And I'm not, like, I don't feel like I've explicitly stated the logic for that. So I feel a bit like I've skipped a step just saying, oh no. No. Oh no, this sucks because I can't use the checker to guide me here. And all the eliminations have been logical, so it's a mistake. Like this. Wait, this wants to be an 8, but it can't be. Yeah. So I made mistakes filling it in. I'll be honest, I need to go to the bathroom really badly, and I'm not gonna be mentally able to clean this up. I think it's a pity that these older puzzles aren't easily fixed, like to add author and title, like all the modern conveyances that didn't exist when this puzzle initially was released. Like, I'd love to do like a session of kind of updating these older puzzles and just fixing the existing data in the database. I don't have a mechanism for that at the moment, but I should implement that and like make myself a little interface for saying, oh, let's fix this puzzle. Wait, if you're saying 2, 3, row 2, column 2, and 8 is minimized, you mean 1, 2? Maybe my mistake is actually very, very early on. But that's the thing, I'm a solver. I use the checker to make sure that my flaky logic is correct. And then without the solution checker, I almost don't enjoy it, because I don't enjoy making a mistake and going back and manually double checking everything. Like, that's a part of the solving experience I really don't enjoy, and I don't my brain isn't reliable in that way. So yeah, I'm gonna have to redo this another time. I don't think I can continue today, but I think I'm okay with this brief testing of the new feature and the other stuff. Yeah, and I probably should have looked because they're both 8s, right? So if one of them is 3, the min-max argument from earlier. Yeah. There's one other thing I wanted to show you guys. So I'm helping out a website called Thinky Games, who are like a non-profit sort of directory and catalog of thinky puzzles, of the kind of puzzles we enjoy, but unlike our sort of static pencil puzzle, grid puzzles, a lot of these are actual video games with with animations and characters and things like that. But they have recently launched a little daily puzzle page, and I should be taking over very soon in the next week, actually, to kind of the post-launch, deal with the post-launch fallout, like bug fixes, feature improvements, and things like that. And I've solved the puzzles of the first. They're called dailies, but they're kind of releasing them in batches, so you're not stuck on today's puzzle. And you also need, it's sort of in basically final public testing, so you have to solve a little riddle to sort of apply to get started. And I asked them it's okay to can I not resolve this? I want to solve this again. Restart. There we go. And they are, under the bonnet, they're basically all pen pop puzzles. And maybe in the future I can do something about that. And they have a simplified interface relative to SudokuPad, so it's all custom, it has nothing to do with SudokuPad. But obviously a lot of the lessons I've learned with SudokuPad I can apply here, so hopefully I can help with certain usability things, especially on mobile interfaces where, for example, the hints don't scroll up and it's not obvious that the box scrolls, things like that. Let's solve this. So this is a Hamiltonian path puzzle, they call it. But I wonder if we have, in the community, have other names for this. And you basically have to connect this path to this, filling the whole grid. And they have a good way of visualizing and explaining the rules. Definitely things I want to do for always do for SudokuPad. So hopefully this will inspire me to kind of, like, something as simple as having these examples with correct, incorrect. You can't run a line across this. Although maybe it should just not let you do that. Maybe that's an improvement we could do. In fact, that's something I'm going to write down in my little notes that are here. Disallow invalid moves such as crossing black on first puzzle. And kind of these kind of notes and fixes and improvements is very similar to what I've been doing for SudokuPad for the last 5 years. So that's kind of nice for me. So for example, since you gotta come, you could go up, I guess, but then you kind of struggle kind of getting in here later. Although I guess you could, you see, you end up with an odd number of cells, and you can't wiggle in and out of this side. So you actually need to take these, I figured out by solving this earlier today, and then, that would be the solution. And some of them are fairly simple. They do have word puzzles, though, which I personally am not good at because I haven't solved them a lot, so I don't know the sort of things that people assume about them. So I would highly recommend checking this out. thinkgames.com/dailies should take you, let's see what page it'll take you to when you're not logged in. You have to sign in with an account, especially currently. Yeah, basically you have to join the preview pass, which gives you access to the puzzles. So you have to solve a little, very simple riddle. All of you guys should figure that out faster than I did. But yeah, let me know how you feel about it. There's obviously their own Discord and stuff, but feel free to poke me on the usual channels if you're curious. Under the bonnet, I hope in the future to push towards more user-submitted puzzles, maybe supporting standard formats like SudokuPad's format and Sudoku Maker and things like that. And their focus, their audience is a lot more video game developers. So I'm hoping to introduce making puzzles as a way of learning the initial aspects of puzzle design for video games. So just like how people are often told, you should make mods for games if you want to become a programmer for video games, I think making pencil puzzles is a good start to get your brain on the right track for thinking about designing puzzles for games like, Can of Wormholes or Parabox or, any of these other puzzles that are, Can of Wormholes is featured here, and like a lot of the puzzles here might be familiar to you guys. If you like the channel Aliens Rock, then you'll be familiar with a lot of these puzzles. They also have an online conference where they've showcased a lot of these developers. Definitely worth checking out. So that's what I'm going to be sorting out as well. And in the meantime, thanks for hanging out, guys. I really appreciate it. GDC, thanks for the puzzle help. Apex82, always nice to see some of the Twitch folks stepping in. I guess you don't see the chats from the YouTubers because I don't have no, I do have an on-screen chat, so occasionally those messages will pop by. And Keith, thanks for being probably my most present viewer. I really appreciate that. That always helps out. And I'll get back to this puzzle. I think I want to make a version with the solution embedded, and then I'll probably go in the video, pull the solution out, embed the solution, make a version that I can play, and then take it from there. Awesome. Thanks for hanging out. And now I'm going to tell Ranks that his feature's in beta, and hope he will test it for me. Take care. Have a good rest of your day. Bye-bye. Where's the button?